Okay, YouTube, this is my fourth video in which we're going to continue working with these strategies that you see on the left here for solving application problems. And this application problem deals with investment. So it's kind of, these are noteworthy problems. We need to look at least one of them. But it says we inherit $5,000. And as we read through this, we're going to underline what we know and then talk about what we don't know. But we inherit $5,000 with the stipulation that for the first year, the money had to be invested in two funds, one paying 9% and the other one paying 11% annual interest. So we have a 9% account and an 11% account, two different accounts. It says, how much did we invest? Okay, so we want to find this out. How much did we invest at each rate if the total interest earned for the year was $487? So we have total interest earned is $487. So the first thing that we always do is we choose a value here, or a quantity that we're trying to find to be represented by a variable, and in this case x. So when you want to determine this, one way to do it is just kind of look at the last sentence here. It usually asks you what you're looking for. So we say, how much did you invest at each rate? So we have two different rates here, 9% and 11%. Let's pick one of those to be represented by x. So we say the amount invested, just because 9% came first, I'm going to choose that, at 9%. Is equal to x, okay? Or in other words, I've been writing it this way. We say let x equal the amount invested at 9%, okay? So now that we have that there, let's come up with an expression for each of the different accounts. So in other words, the amount at 9%, this one's easy. We're going to let that be represented by x. But the interesting thing here is if I said the amount at 11% interest, the thing is we had $5,000 total dollars. So if we said, well, how much is invested at 11%, we'd say, well, it'd be whatever's left over after we take our original $5,000 and we subtract off the amount we invested at 9%, which happens to be x. So what's going to happen here is essentially this. We're going to say, well, this would be the original $5,000 minus the initial x that we invested at 9%. But now that we have these two quantities, let's try to come up with a verbal model here. We were told that the total interest earned for the year was $487. So total interest earned is $487. So when we calculate interest, let's talk about this. That'd be the interest that I made off the amount that I invested at 9% plus the interest that I made off the amount invested at 11%. That has to add up to be $487. So interest at 9% plus, well, we say interest on the amount at 9% plus the interest at the amount at 11% is equal to $487. So all we need to do now is come up with an expression or an equation in terms of x that would represent this statement right here. So the question is, how do I calculate the interest that I earn at 9%? Well, what you do is you say, well, I need 9% of that number, and we're allowing that number to be represented by x. So essentially what we're going to write here is this. If I want 9% of x, remember to find 9% of a number, you take that number times 0.09. So we say 9% of the amount that I invested at 9%. If I add that now, if I add that to 11% of what I invested at 11%, which we're representing in terms of x this way. So we're going to say now 0.11 of this amount. This comes out to be $487. And so now we finally have our equation in terms of x. What we can do is we can go and solve this equation here. We'll probably need a calculator, but we say, okay, so 0.09x. We'll distribute this 0.11 through here, or 11 hundredths. So I get 0.11 times 5 grand. It's 550. So we say plus 550. Now 0.11 times 11, or negative x here, is going to be negative 0.11x. And this comes out to be 487. So now I'm going to combine my like terms. Combining like terms here, we got like 0.09 positive and 0.11 negative. It's going to come out to be a negative 0.02x plus this 550 right here is equal to 487. So now subtracting 550 from both sides of this equation to help us isolate x, we have negative 2/100 of x is equal to, now using this calculator here, I say, well, minus 487. There's a difference of 63 between these, but it's a negative difference. So we say now we'll divide both sides by 0.02. That has to be negative as well. So we've got a negative divided by a negative on the right here. But we've isolated x. And so we say x is equal to that 63 there, which was negative, but divided by a negative 0.02 makes it positive. We'll just divide this by a positive 0.02. We get 3150. So I say 3150, and this is dollars that we're measuring it. So now what we've just found is the amount that we invested at 9%. So if we want to find the amount that we invested at 11%, all we need to do is substitute that amount x here, which we know x is equal to 3150. But if we plug it into this expression right here, we could say, well, 5,000 minus 3150 should come out to be 1850. And we can certainly check this in the initial conditions of this problem here, but if we look at this and we say, well, if I invested 3150 at 9%, 9% of that, so we say times 0.09, is equal to this 283.5. So I'm going to memory plus this, and so now it's in the memory of my calculator. And we say, well, if I invested now 1850, and I get 11% of that, we take that times 0.11, I get this amount, plus now my memory recall, adds up to $487, and certainly these two things add up to the initial 5,000.